Well, good afternoon to everyone. I'm Keith Pitcher. I'm a member of the institution's Renewables Power Committee, and I'm your chair for today. First of all, I'd like to welcome you to the webinar, Domestic Heat Pumps, Myths and Opportunities. Our committee engages with engineers, with industry, financiers, NGOs and governments. It's really to promote effective knowledge sharing of the technologies, how they perform, what policies are needed to assist in the continuing development of the renewable energy sector. Heat pumps are a really important part of UK's policy and its programmes to help decarbonise our heating. And the institution's recent report is called Engineering a Net Zero Energy System. It focuses on the solutions that are available and that are needed to achieve net zero. And heat pumps feature very strongly as one of the solutions. So for today, our webinar will begin with three short summaries. They'll look at several aspects on technologies, cost, performance, government policy and support, and so on. And then we will then have a panel discussion to go through these and answer any questions you may have. If you'd like to submit a question, can you please use the chat facility on your screen? Our speakers are, first of all, Bean Beanland, who's Director for Growth and External Affairs at the Heat Pump Federation. Bean will be followed by Chris Whitelock, who's Chairman of Pure Renewables. And our final speaker will be Bill Jenkinson. And Bill works for one of the energy catapult systems as an advisor for building decarbonisation. And our panel discussion will be led by John Lochhead, and John is also a member of IMechE's Renewables Power Committee. So I'd now like to ask our first speaker, Bean, to give his presentation.
Right, hopefully this will share the screen. Good afternoon, everybody. Firstly, thank you very much indeed for the invitation to address your institution. This, for us, forms part of the work that we have ongoing with engaging with professional bodies across the UK. The Federation was formed primarily to provide an umbrella for a coalition for lobbying in support of decarbonisation policy, but has morphed into something rather more as we've grown up, shall we say. So look, the view from the top table, I'm just going to give you sort of 5 minutes or so on where policy's got to, why electrification is important, and hopefully that will sow some seeds for your discussion, for the discussion panel later. So look, Rishi Sunak came into power with some really quite heartwarming statements. You know, no long-term prosperity without action on climate change. Running through to we can bequeath our children a greener planet and a more prosperous future. And finally, of course, there really is room for hope. Well, let's hope so. So warm words, but where are we? So we've had 24 months of government policy publications, and there's a whole load more that I could have put onto this slide. But fundamentally, the only actual action that we've had from all of this is the interim update to building regulations of last June, which has made some modest changes in, first of all, actually in improving the efficiency of fossil fuel boilers. But we are still waiting for a raft of policy updates to come through that are related to all of these others. And several of them are key to the question, which I think is probably front and center, which is the target for 600,000 heat pumps a year by 2028 still realistic? I would say at the moment it is, but we do need some very significant action in order to deliver that, primarily around the banning of fossil fuel boilers in new build, which will come in the Future Home Standard, all being well, 2025, and the phasing out of the installation of replacement fossil fuel boilers off the gas grid. And at the moment, those are slated for 2024 for large commercial, 2026 for everything else. So very soon. And if government doesn't start making the moves on that, they won't actually have the legislative program available to get those in place. So why is electrification carbon efficient? This is a screen grab from an app which sits on our website called Carbon Watch. I actually took this at 1:30 yesterday. Yes, yesterday afternoon. At the time, in the box in the top right-hand corner, you can see that the grid was running at 88 grams of CO2 per kilowatt hour, which is actually very low. The building regulations figure at the moment is 233. So it was clearly a nice windy day because the bulk of that carbon reduction is coming from offshore wind. But you can see here that the carbon content of heat pumps operating at what is broadly a ground source and air source efficiency rate. You can see in the top two bars, the gold bars in this bar chart, are far outstripping even natural gas. So it's clear that as we decarbonise the grid, that the decarbonisation of heat can be achieved very significantly by electrification. When we talk about heat, of course, we're also talking about hot water, potable hot water, process heat, and cooling, indeed. And we shouldn't underestimate the value of low and ultimately zero carbon cooling, particularly as average temperatures seem to be on the increase. So again, why is electrification energy efficient? So this graphic was put together by the Hydrogen Science Coalition, and what it shows is the pathway for delivering domestic heat, either via an electrified heat pump scenario or via a hydrogen, 100% hydrogen scenario using the existing gas grid, if that were ever to prove technically feasible. And what you can see is that the requirement for offshore wind turbines to produce the zero carbon electricity, to produce the genuinely green hydrogen, and it has to be green hydrogen. The scale is enormous, 6 times more wind turbines required in order to deliver the equivalent amount of energy. And of course, the grid itself has to carry 3 times the volume of gas because of the volumetric energy content of hydrogen is that much lower. So there are still some enormous technical challenges for the hydrogen route. So clearly from our part, we're very keen to see the electrification route heavily pursued by government at this point in time. Why is it a challenge? So actually, I've said why is electrification a challenge? I should have said why is decarbonising heat a challenge here? Because UK housing stock is amongst the worst thermal performer in Europe, as you can see in this graphic. This shows the reduction in temperature, internal temperature, after 5 hours with a heating system turned off. You can see that the UK is at the bottom of the scale, as it is in many things at the moment in decarbonisation. But the key to remember here is that the building doesn't know where the heat's coming from. So this isn't actually a heat pump problem. This is a heating system problem. And the fact that we now have 55 degrees centigrade as the common design flow temperature in building regulations for all heating technologies, including condensing boilers, which are a low temperature heating device, is good news in this respect. So why aren't the economics simple? So the graphic here shows, up until October, it showed the makeup of an average domestic gas and electricity bill. And the piece we're interested in this morning is the green wedges. So on the gas bill on the left-hand side, the green wedge is the social and environmental obligation cost, sitting at a mere 1.86% of the bill. Whereas on increasingly clean electricity, it's a whopping 22.92% of the bill. So clearly we have a taxation regime which supports the burning of fossil fuels. Very swiftly looking at the cost issue, it's always been said that the cost of the transition is far too high. A typical gas combi boiler, these are Viessmann units as it happens, £2,500 for the combi, but they're doing 1.8 million units a year. The equivalent Airsource, £6,000, so over twice the price, but only on a market of 60,000 units a year. So clearly there are some economies of scale to come. And the transition costs, which are the one-off, are those that the schemes such as the boiler upgrade scheme are designed to make provision for. And then on an operational perspective, under the Ofgem price guarantee, 34 pence per kilowatt hour for electricity, 10.3 for gas, an SCOP, so a seasonal performance factor of 3, which is very achievable for Airsource, achieves parity in operational costs with a gas boiler at 90%. So from the coalface, to change this now, can't be from the coalface. So our technology is moving into the mainstream, no doubt about it, almost in spite of the politics. And it is now politics, not policy. Training capacity is climbing fast, new apprenticeships starting in 2023 in September this year. Manufacturing and drilling capacity is increasing, and we're demonstrating in many ways that the industry is now investable. There's a massive determination to innovate. The UK is actually very strong in low global warming potential refrigerant use. So the heat pump sector is actually in surprisingly good shape, and it is a bit of a coiled spring, but we've got to be careful, because if we do not release that spring soon, metal fatigue could well set in. And just one for the future, this question about flexibility, and I hope many of you are thinking about flexibility, the value of flexibility, flexing when we use electricity to meet the increasingly large proportion of flexible generation, has an enormous value, and we must release it. 16.7 billion pounds per annum by 2050 to be had from that. And lastly, a reminder, because I'm based in Wiltshire, we have to remember where our energy comes from. And it doesn't matter what sort of renewable technology you're talking about, whether it's biomass, wind, solar, obviously, heat pumps, all of this energy is coming from the sun. So Stone Age didn't end because we ran out of stones, and the oil age will not end because we run out of oil. Thank you very much indeed.
Well, thank you, Bean. I'd now like to ask Chris if he would like to give his presentation.
Good afternoon all, and as Bean has said, it's a pleasure to join you on this webinar. And my task today is to just talk a little bit more about the how a heat pump works and what it can deliver for the homeowner. So hopefully you've got it up on there. So heat pumps are a significant player in our future energy mix. They've been around for decades, principally mainland Europe, but we all have one. Fridge freezer is basically a heat pump. And they counted as a renewable technology due to the fact they're non-emissive at the end use, and they generate more energy than they consume. And the UK's Renewable Energy Directive lists the following renewable fuels as being wind, solar and hydro, bioenergy for combustion of plant and animal matter, waste energy such as landfill gas, and aerothermal, geothermal and hydrothermal energy, heat from the air, ground and water respectively. So heat pumps are a significant mix in the future, significant player in our future energy mix. And the options for electrification of heating, which is really where it's where heating is going, is either direct electric panel heaters, which are cheap, but they are inefficient and require ordinarily very chunky main supplies, especially if you've got a large number of panel heaters in a property. Or the alternative are heat pumps, which are more expensive than a gas boiler, but they are subsidized, are very efficient and don't require chunky main supplies. What I will say on this, and actually in answer to a question that's just popped up, is that really heat pump systems do work very efficiently, but critical to them working efficiently is the design of the system. So they have to be designed to be fit for purpose for a property. If, as in the early days, there was a bit of a finger in the wind approach to sizing heat pumps to a property, even new build properties, then that's often where issues and problems arose because heat pumps were sometimes undersized, which would mean that they would cost a lot to run and wouldn't be effective. But a well-designed system should be very efficient to run and very effective. So heat pumps play directly into the UK's decarbonisation strategy. The heat pump should reduce carbon emissions by up to 68% against a mains gas boiler operating at 92% efficiency. That's the boiler operating at 92% efficiency. And by around 79% versus an oil boiler operating at 89% efficiency. So you can see there that the carbon emissions are greatly reduced by using a heat pump. And really, that's coming down to the generation of electricity that is running them. So very briefly, what is a heat pump? I think most of you will be familiar with how a heat pump works, but effectively you're taking what we call low-grade heat or energy from the air, ground, or water. And that could be 4, 5, 6, 7 degrees. And we're taking that back to a refrigerant cycle within the heat pump. And that energy is transferred across to refrigerant gas, which is compressed in a compressor, and that's where the multiplication of the heat happens. If you get a bicycle pump and you pump it against your finger, then it gets very hot because you're compressing the molecules. So the same principle with a heat pump. And then that high-grade heat is transferred across to your heating and hot water circuits. As an example, case study, this is a hall up in Yorkshire. And we undertook a feasibility study on this hall. 300-year-old property sat in 10 acres of land, but actually also had a very nice, reasonably large pond. It wasn't huge, but it was spring-fed from the bed of the pond, and there was a constant 12-degree supply of water coming up from the spring underneath it. And that was perfect as an energy source for the heat pump. So we put in heat exchangers into the pond, and that system on this old property, not particularly well insulated, is returning a very healthy COP of 3.8 over the life of the system so far. And it also needs to be noted, actually, that the client did not upgrade his radiators. He wanted to stick with them. They were column radiators. So we put an oil backup boiler in, and actually the backup boiler has hardly contributed to heating the property. It's all coming off the water source heat pumps. So you need to consider the full life aspects of heat pumps. So they have a much longer life than an oil gas boiler, typically 2 to 3 times. And they should cost considerably, a lot less, can't say the word, to run compared to an oil boiler, and less to run than a gas boiler now. That's recently changed with gas prices going up, where a heat pump is seeing run cost savings against mains gas. Heat pumps typically are lower maintenance. You don't have burners to maintain, and also the efficiencies on a heat pump don't decline over time. And there's no risk of explosion or carbon monoxide, nitrous oxide, etc., at the point of use. You also need to consider the full prognosis for energy costs. Future prognosis for energy costs. Some of these utility companies now are looking to offer heat pump tariffs for people on heat pumps. That should obviously be a lower preferential tariff. Fossil fuel taxes are going to increase, and also lower electricity prices are coming due to decoupling of electricity from gas, because more electricity is being generated renewably. And generating electricity renewably is far cheaper than generating it through gas-powered fire stations, electricity stations. So price of gas and oil is likely to become more volatile as well, as we're more reliant on having to import it. The other thing is that there's been myths around the fact that heat pumps don't work with radiators. They do, but you typically have to upsize them. And again, this comes back to good design. But there are also more radiators coming on the market which are designed to work with low temperature systems. And so case in point here is a radiator that will output the same amount of energy into a room than a typical sort of double convector size radiator would at a much smaller physical size. And they do this because they've got a very fine radiator within the radiator itself, and also have booster fans just sitting on top of the heat exchanger, which just blow the heat gently into the room. And that is it for me.
Okay, thank you, Chris. And now our final speaker is Bill, and I'd like him to give his presentation, please.
Hi, good afternoon and welcome. Thanks for agreeing to have us today. It's a pleasure to speak to you all. So just a quick introduction first into the Catapult Network. As we say on the slides, 2 minutes, I've got to put it in presentation mode. Sorry. There we go, sorry. The Catapult Network supports business into transforming great ideas into valuable products and services. It's a network of world-leading technology and innovation centres established by Innovate UK. We deliver impact across the whole of the UK economy, enabling businesses to thrive in global markets. The Catapult is where the application of research is accelerated, where further new technologies are further scaled and realised. All catapults are part and parcel of a network, but they all run as individual businesses. Just click forward. So I'm from Energy Systems Catapult, and we look at the whole system of the energy network. So we consider heat, electricity, transport, industry, infrastructure, and the consumer. We do this by working with innovation experts and with other partners and collaborators. We support innovators to commercialise, and we help design the future energy system to unlock innovation. We do that by having capabilities, which I won't read to you, but they're all on the right-hand side. So things as consumer insight, right down to integration of transport and energy systems, but real system engineering as well. We're non-for-profit. We were set up in 2016 with the aim of accelerating the net zero transition. This is one of our assets that we've got called the Living Lab. This is over 1,700 homes. And what we do here, it gives us simple interaction with customers. So it's customers' homes. So it's a real lab that's out there. We often do trials for individual companies, but we often look at innovative products and how they impact customers' lives in their homes. We also have a subset of the Living Lab, and this clusters a neighbourhood or a city. And what this does, it gives us the ability to test grid conditions from signals from PNDC in the University of Strathclyde, and then applying those signals into part of the Living Lab. So today, we're here to speak about a recent trial that we did of 742 heat pumps that were installed in domestic homes. These were installed in a full range of different archetypes, so detached, semi-detached, flats, terraces, and end terraces. There were a range of homes that are typical in the UK, so across right from pre-1919 right up to present day homes. The news here is that we always found a technology solution that could work, a heat pump technology that could work in all homes. So they were all deemed suitable for a heat pump technology. While we always tried to improve the fabric of the home, but it wasn't always possible. But I think the news there, and you heard this from Chris earlier, that heat pumps still worked even when we weren't able to upgrade the insulation in the homes. So how we measured real world performance. So if you look at the picture on the top left, this gives you an idea of the equipment that we installed to measure the efficiency of the unit or the system, more importantly. So if you look at the equations below, and you look at the diagram in the bottom left-hand corner, this gives you an overall idea how heat pump efficiencies and system performance is measured within homes. And these are the results. So we've tried to be quite, we've tried to present this in a very graphical way. So what you can see on the left-hand side is the real-world performance of all the heat pumps within the trial. And you can see without concentrating on the outliers, generally we were getting up and above an SCOP, if you look at SPF 2, which is the heat pump efficiency of around of above 3 or round about 3. The performance of a heat pump is affected by many factors, and that includes whole system design and specification, quality of installation, effective control strategy, heat distribution, and emitter design. External temperature is obvious, and the position of the outdoor unit is crucial to getting better performance from your heat pumps. During the trial, we were quite surprised, really, in a way, that we saw this leap in performance of heat pumps while we were in progress of installing this or monitoring this trial. And we noted that there was a great step in performance and change in performance from other heat pumps. And these were heat pumps that were based on new refrigerants that have got lower global warming potential. So the innovation had come through the heat pump industry. And what they've done is they've used R290, which is propane-based, or R32, which is a new refrigerant gas. And what they've done is they've managed to get better performance from their heat pump. Now, obviously, heat pump efficiency or any efficiency can be used in several different ways. So you can either use it for higher temperatures, higher efficiencies at lower temperatures, or higher design flow temperatures while maintaining good efficiency. The advantage here is that you can use, you can have a lesser impact on a deep retrofit in a home, so you don't have to necessarily upgrade the radiators if you take that high temperature system. Just thinking about what next, this ideally captures I suppose, a future energy home. I'm thinking about the technologies that we all will have within our homes in the future. So we've got several benefits and several future value streams that we know are there and they need unlocking. So the first one is the micro benefit, and the micro benefit is for the individual home. So the interoperability of all technologies within the home, so everything can speak to each other and make sure that we're getting the maximum efficiency and the maximum cost benefit to the end customer. The better benefit would be the benefit to the low voltage network, so pre the substation. And what's happening there is that you can see the data flows are allowing you to understand at a very high level, or the system to understand at a very high level, what your neighbour's doing or what your neighbour might do and their behaviour in the next few hours. So that gives us the ability to be able to utilise these local micro assets in a community basis, and ensure that we can unlock some of these valuable assets within people's homes. The macro benefit is the overall benefit of the large, or the utilisation of the large renewable generation that we've got on the high voltage grid or the transmission network. And obviously we want to use them when it's windy and when it's sunny. We want to be able to utilise all these systems within the home, because that'll give us the best possible outcome in terms of the full renewable cycle, if that makes sense. So I'm going to leave it there, and I'm going to pass back, if that's good, to
Thank you, Bill. Well, that completes our first part of today's event, and I'd like all the speakers to rejoin, please, and also John Lockhead. As I said earlier, John's also a member of our Renewables Committee. If you haven't already sent a question or comment via the chat facility, please feel free to do that. And I'm going to hand over to John now to go through all your questions and comments.
Thank you very much, Keith, and I'm going to apologise right up front. I won't be able to go through them all, but could I just start by answering a general question? There is going to be a recording of this event, which will be available to all participants. So one or two of you have had some problems with streaming, so you can overcome that. Right, so could I start then by combining a couple of questions, one of which is talking about the difficulty of people finding someone who can actually do a design and installation of a heat pump system, coupled with another comment from a participant who said that their son had an Airsource heat pump in a new house 9 years ago, which has proved unreliable, expensive and unresponsive. And in trying to clear this up, the comment was the installer clearly didn't understand what they were doing. So I'd like to kick off initially, if I could, with that to probably Bill, I think, who just commented about the ease of installing systems, and then Chris and Beam might like to come in. Bill.
Sorry, I was coming off mute. I was reading the question. Sorry, I was reading the question in full, so apologies for that. Apologies for that. So I think if I answer this in a roundabout way, I think it's a really valid question. And I think we've really seen some poor installations of heat pumps in not only in new build, but also in retrofit. It's quite clear that the skills gap needs addressing. And it's certainly one of the ways that that is crucial to actually getting this government strategy in place and to get the realisation that we do get good quality heat pumps being designed by professional people and installed to the right manner. So I think a question to go back to the IMechE, I suppose, in a way, do we see there's a need for engineers to really be designers of the future of heat pumps and specifiers? So do we want it to work like you might do for a commercial building, where you get a classical M&E consultant that does the design specification of the system, and then the installer goes to install the equipment to the specification that's been made by the professional, if that makes sense. So that should answer it in a roundabout way, but there is a massive skills gap here, and we see that as an industry, and we are trying to address that as we speak.
Great, thank you, Chris. Your experience in this, have you got any comments?
Yes. Can you hear me?
Yep.
Yeah, I actually answered that question on the chat, but what's absolutely imperative with low temperature systems is the design, and the design is fit for purpose, because I liken it to having a car with a very efficient engine but flat tires. You're not going to get the efficiency out of the engine because of the resistance, all that kind of thing. So in a similar way, you can put a heat pump, specify a heat pump to a property, but if the radiator distribution system is not up to is not able to deliver the energy into the room because it's getting lower temperatures into the radiators, then you're going to have issues of performance and also cost. So design is absolutely imperative. And I think as Bill alluded to, the issue really is lack of training And there's we've got a problem with the skill base in this country. Heat Geek, somebody mentioned that on one of the chats. We're actually putting all our technical staff through that as we speak, because that's a very, very good qualification, which covers the whole aspect of design and also installation. But it really gets us to understand, the theory behind the design aspects. And it also, it has to be said that this was 9 years ago that this installation went in, which back then, quite frankly, there was not a lot of skill or experience or knowledge in the industry. And so you were having people coming along who were applying the same kind of design approach, if you like, to putting an oil boiler and a high temperature boiler in, or a gas boiler, and applying that to heat pumps, which is never going to be a recipe for success, quite frankly. That, I think there's been a lot of improvement in all of that, and MCS have helped with that. I agree MCS is not perfect right now, but it certainly helped a lot in terms of improving the standard of design and installation of heat pumps going in.
Just picking up on the chat as well, and just to carry on the conversation and the debate that Chris is having at the moment, I think it's worth talking about and realising, and I think Chris and I can pick this up between us. I'm sure he won't mind. There's some talk in the chat around when you replace a boiler, it's a like-for-like boiler swap, but generally when you put a heat pump in, you might have to replace the pipework, you might have to replace all the radiators. You might have to is the talk on the town, let's say. And some of that's true, and there is some truth in that, but that's not every case, right? That's not absolutely not every case that you always have to rip all the pipework out of the house. I think the key here is to realise that if we truly believe that all those boilers are condensing and actually running at 55 degrees, then the pipework, the radiators, should be sized already to cope with that low temperature system, right? So it's not a heat pump problem. This is a heating system problem, right? So low temperature condensing boilers should be running at 55 degrees return, right? Otherwise they're not condensing, so you won't get the efficiency out of the boilers. So let's split out the central heating arguments away from the heat generation solution, if that makes sense, because it's a heating system problem, not necessarily a heat pump issue, if that makes sense. So yes, if it's a poorly designed system, you will have to upgrade the pipework, you will have to upgrade the radiators. But if it's a well-designed system, and believe me, I've been there on the cold face, I've done it, you can a well-designed central heating system will adapt really well to a heat pump.
Okay, thank you, Bill. Bean, would you like to comment on the main point, which is, are we actually in a position where people are competent to install these systems?
Yes. I think that the important thing here, and Bill sort of started to allude to it, is that what's going on in the house isn't actually a heat pump problem. In 2005, we changed building regulations to mandate the deployment of condensing boilers, but failed to mandate that they be deployed in such a way that they entered condensing mode for most of their operation. So we spent the last 17 years patting ourselves on the back and saying, there you go, we've got condensing boilers. There was a tweet about 18 months ago that said at any given time, only 1% of the UK boiler fleet is in condensing mode. And the boiler industry did not push back on that, which suggests they don't have the data to say that's true. So this is an inherited problem because condensing boilers are low flow temperature devices. And so we should have been progressively changing all of the emitter systems, pipework if necessary, and that's rare, I must tell you, progressively since 2005, if we got building regs right. The fact is, this problem is now being laid at the doorstep of the heat pump industry. It's not a heat pump problem. The boiler refresh over the last 17 years should have picked this up in the vast majority of homes. It hasn't. and the UK has been addicted, and I mean addicted, to ultra cheap natural gas for far too long, and that particular turkey is now coming home to roost.
Okay, thank you, Bean. I'd like to go back to Chris with a question that spins off this, which is that there have been reports saying that air source heat pumps are really only suitable for about 1/3 of UK properties. Is that correct?
I think we always start with a fabric first approach, and with any heating system, a well insulated property is going to be more efficient than a less well insulated property. We've successfully installed heat pumps into older, what they term hard to heat buildings. Typically, actually, ground source performs better on those than air source, but we've successfully installed air source on, air and ground source on those types of properties. And when I say successfully, what I mean by that is that they have kept the building warm at SCOPs of 3.5 to 4, and also, you know, have performed well. They haven't fallen over. Now, with our approach is that on those hardest to heat buildings, we would typically look to do a bivalent system, where we would retain within the system a fossil fuel boiler to be able to pick up in very cold weather where the heat pump may not be able to deliver. Now, actually, what we're finding is, like in that case study I alluded to, is that it's very rare that the fossil fuel boiler actually has to operate. And you know, I think as Bill was saying, you know, as long as the system is designed for the building, then there's no reason why they shouldn't work well. But it does come back to this thing of, you know, regardless of what kind of heating system we're putting in or heat source we're putting in, we need to be attending as much to the insulation of the building as anything.
And just one more thing to add to what Chris has just said. Some of the new refrigerant gases that we're seeing in the industry, certainly we're seeing a lower drop off in terms of performance. So actually they're coping better with colder days. And I think that adds to Chris's argument around, leaving a fossil fuel boiler in by all means as a backup. But I think it's proving less and less necessary these days with the innovation that we've seen in the heat pump industry recently.
Okay, thank you. There's another question that I think is important in that there's a question here that somebody commented on the value of government grants in supporting this. So there's a key question. Are heat pump systems actually financially viable in comparison with gas boilers today? I'm going to go to Bean for this to start with.
Okay, so look, I mean, clearly the transition is expensive. You know, making a transition between fossil fuel systems and heat pump systems has a significant cost. No getting away from that. But I would suggest we've been here before. There was a time when central heating was said to be for the rich and famous only. Now you can't find a house without it. So we've had these big transitions. We've managed to find the money, and it hasn't bankrupted us. So I think that we will get through this. But right now, absolutely, the transition cost is high. And the operational cost benefit isn't yet good enough because we continue to subsidize natural gas and penalize increasingly clean electricity in the UK. Now, when that changes, demand will rise, and there's a huge amount of work going on in the background to create innovative funding models that will start to get the capital to where it needs to be in order to make the progress. But you're right. Right now, at this point in time, today, it is a problem both from a capital perspective and an operational cost perspective. But if we, I keep coming back to this, if we believe that climate change is real, then we have to collectively do something about it and choose to do something about it.
Thank you. Bill, have you got a view on this?
Yeah, I think heat pumps remain expensive. At the moment, yes, I agree. And it's all to do with economies of scale, right? I think when you look at the 1.6 million replacement boilers that we sell in the UK every year, right? If we get heat pumps up to that stage, then I think heat pumps will be as cheap as gas boilers. And this is a heating industry problem that we've got to scale. We've got to be able to make units affordable, good quality. And it's a real engineering problem, right? So it's a real supply chain. What I'd point you towards as an example of where we've really seen engineering excellence is something like offshore wind, where it was crazy prices at one stage and people said, oh, it'll never come down in price. But through good engineering and supply chain work, we got there. And now offshore wind is the cheapest form of energy, electricity in the UK currently. So at that stage, you go, well, it's not an insurmountable issue, this. It just needs the economies of scale to come in. The other thing that Bean and I often discuss is quite often heat pump installs are done by single, smaller SMEs. So small, I think when you look, it's something like 80% of all heating installs are done by small family businesses, which is great. But I think when you think about the small amount of heat pumps that are currently sold in the UK, that means that you've got to do an awful lot of work if you do it correctly in visiting lots of homes, measuring lots of homes, doing a heat loss calculation room by room, making sure the radiators and the pipework is correct for the heat pump. Now, let's say you've got a strike rate of 1 in 20 people buy a heat pump at the end of it. What do you think happens to the other 19 designs that you've got to do, right? At the cost of the other 19. So the cost to serve or the cost of sale of a heat pump is really big at the moment because there's so much effort going into that one heat pump sale, if that makes sense. So when we get the economies of scale, it will come down in price. Absolutely.
Okay. Any thoughts from you, Chris, on this? You're in the area.
Well, I agree with Bill on that. I think we got a lack of volume issue going on, haven't we? And as been alluded to back in the 70s, gas boilers were pretty expensive because there weren't many of them going in. So I think it is expensive at the moment. I think with the bus scheme, that's helping just to sort of ease the upfront cost a bit and bring it a little bit more in parity with a gas boiler system. But my view is that actually it's not enough. There needs to be more incentive from the government and more support of this to enable the uptake of heat pumps to accelerate. And the 600,000 figure of heat pump installations per annum is very, very ambitious. But I think, as somebody has just alluded to on the chat, actually, if you look at the uptake of EVs, how that's accelerated incredibly quickly over the last couple of years, there should hopefully be an acceleration of heat pumps going to the market, and therefore the costs should start coming down.
Okay, and just a supplementary from me, are we in a position where we've got the resource to actually achieve that many installations? Because there has been a previous comment about lack of a resource, skilled resource.
Well, yes, I agree, and this is where the big disparity is at the moment between how the ambition, if you like, and the practical ability to be able to deliver that ambition. But there is more training coming on stream, both from manufacturers and also from accreditation bodies and qualification bodies as well. So I think again with that that's going to help the acceleration and the uptake of it.
Okay, so I've got another question here, which is and a brief answer for this, I think. Should we be looking at individual heat pumps for individual properties, or looking in the round, is it going to be difficult for people to get enough space? And should district heating solutions be considered instead?
Yes.
Thank you. Thank you for that, Bill. That's a very brief answer. Bean.
yes, he's right. Yes, of course it should. And you're quite right. And the idea of individual heat pumps in every single dwelling, in every urban environment, is almost certainly a non-starter. But we are beginning to get to grips with heat networks. You know, if you look across on the continent, you know, vast cities have been retrofitted, and they have been retrofitted with heat networks. So it's perfectly achievable, but we need a will to be able to do it. And for me, the real benefits here are being able to capture waste heat and sources of heat that currently we are either ignoring or just literally throwing away. So if you put a heat network in, it's driven by captured waste heat. The efficiencies and obviously the carbon gains can be enormous. So absolutely. And there are lots of ways of doing district heating, you know, district networks, lots of archetypes that we're looking at, from relatively modest sort of heat my streets approach things to whole centralized district heating solutions, such as going in on the Clyde, in Glasgow and in Bristol at the moment. Lots of other metropolitans also looking at them. So yes.
Okay, thank you. So we're coming towards the last few minutes of time available for this. So I'd like to try and get in 3 other questions, if I can, in that time.
Just a really simple one that somebody's asked that we can answer very, very quickly in this time. It'll take me 10 seconds. Why is position of heat pumps important? Somebody put in the chat. I alluded to it earlier. So it's all to do with individual siting of the heat pump in that property or outside that property, wherever that heat pump's going. And one of the biggest fall downs here is when they actually put it too close to an object in front of it. So what's happening is the air source unit or the fan is blowing against the wall. It then hits the wall in front and then recycles back the cold air towards the back of the unit. So this is where you get a drop off in performance quite often, because the cold air is not getting away from the unit itself, if that makes sense. So you get a recirculation effect of the cold air coming back into the hot heat exchanger again. That's that one answered.
Thank you, Bill. So there's a question here that I think is quite important about the future developments of heat pumps themselves. What are the likely nature of developments and what impact on efficiency might be achieved from that? So Chris, do you want to kick off on that one? What's your view?
Yeah, I think there's some big inroads being made in terms of the size of heat pumps. You know, the outputs from heat pumps from single units are increasing year on year. And when we're coming back to the district heating question, you know, there's some out there that now are able to output, you know, a megawatt of heat. And I think there's advances being made in refrigeration as well. So R290 at the moment is you know, able to produce high temperature outputs at reasonable efficiency still, and so there's going to be advances on that, and I think also the other areas on the whole control side of things as well. You know, incorporating more artificial intelligence to the control side of things, enabling us to be far more efficient in how we heat our properties.
Okay, thank you. Bean.
For me, the biggest innovations now are all around funding. We've got to create new mechanisms, new funding mechanisms that allow the UK to mobilise the huge sums of money that are going to be required to make the transition away from fossil fuels. So yes, there will be technical developments, and actually the UK is leading the way in many low global warming potential refrigerant developments, particularly in the commercial heat pumps. So you know, we do have some significant players making really good progress in that area. But for me now, it's all about how we innovate around the funding of the decarbonisation piece.
Okay, and Bill, briefly, what do you think is the biggest opportunity for technological development?
I think a little bit like Bean. I think the discovering and finding mechanisms to reward customers for future value streams, I think is crucial. So it's really, so if we're going to bring flexibility or demand side response in, and we're going to really do it domestically, can we aggregate the assets that are in customers' homes up, and can we use them in a better way to provide and reward customers for providing these services that we might need in the future.
Okay, and a final question that is slightly off topic, but actually important, which was, if everybody does install heat pumps, have we got a problem with supply of the necessary electricity? Is the grid able to cope? So, Bean.
Well, I mean, yes, we're frequently asked this question, and you're right. Again, if we're all converting today, there would be a problem. But this is a progressive transition in the same way that moving to electric vehicles is a progressive transition. The key for us as UK PLC is to try and make sure that our generation capacity of low to zero carbon electricity and our distribution capability keeps up with that demand. And this is where flexibility has a value, because if we can flex the demand, we need lower generation capacity and, critically, fewer wires in the ground. So really important that we get into the habit of saying we've got a grid constraint, switch something off, rather than we've got a grid constraint, open up peaking plant, which at the moment is frequently diesel being burnt on the continent.
Okay, Bill, briefly, if you would, please, because we're running out of time.
Yeah, fine. So the answer it has already been alluded to, but obviously, where we can do fabric improvements in homes, so homes that are, that can be treated easily, or even if they're treated difficultly, right? Even if they're hard to treat, hard to heat homes. If we do improve the fabric of the homes, obviously that lessens the grid impact of any heat pump that's installed in that system. And when you aggregate that up, then at the moment, the DNOs and the DSOs are telling us that actually the grid will keep up with the innovation. So they're quite confident that the grids of the future will be good enough to actually support heat pump rollout. So
you're confident. And Chris?
Yeah, I mean, I agree with Bill. I think the DNOs are increasingly understanding that more and more stuff is going to be electrically driven. Heating as well as our transport, etc. So there's big investment going into upgrading the grid.
Okay, well, look, we have to stop there. Thank you very much for your answers. Apologies to those who didn't get their questions answered, but I'm sure the panelists will be taking them home and sending personalized responses to them going. And I think what's come out of that is that we've only really touched the surface in the time we've had available today. But I think the big issue that's come out is the importance of effective system design and the question about whether we're actually equipped to do that at the moment. So with that, Keith, I'll pass back to you.
Thank you, John. I'd like to, on behalf of all of you, thank our speakers for the contributions to today's webinar. I hope we've tried to answer some of the issues. But as John said, I think we will need more time in the future to look at a number of these aspects, including the installation capacity, the training, the qualifications, and so on. Looking at the costs, both for designing and installing it, and their operation, and the technology advances. So what I would ask is if you have any comments on these, any suggestions on these, the institution would really like to hear from you. We will look at all of these, and I'm sure there will be future events that we will be planning to explore these in more detail. So do look out for these on our web pages. Also, if you would like to assist our Renewables Committee in any way, do let us know, get in touch with us. We're pleased to hear from you. So in summary, once again, thank you very much for attending today's webinar. I hope you did enjoy it and you found it valuable. So good day.